brought fossils for you to look at and acquire if you're interested. And he also, he's worked with CAPS for a long time, Creation Association of Puget Sound, and he was on the board there, very active. He's got a degree in chemistry, and the thing that is relevant to his talk today is he has actually led quite a few tours of the Badlands Dry Falls and Scablands out in eastern middle Washington. Some of you may have gone to Mount St. Helens and looked at the evidence that they present there for a young earth and for the truth of the Bible. This is another example of the truth of the Bible, and Ron will talk about that. And let's bring Ron up.
They are indeed badlands out there, that's for sure, if you've been there. We'll wait for them to bring it up. How many have been to the Dry Falls area before? Okay, you said that you lived in Soap Lake, right? Anybody from that area? Where are you from?
Well, originally Waterville.
Waterville, hey, on the Waterville Plateau. Okay, anybody else? Okay. Well, I grew up in Pasco, in the Tri-Cities, and all the years I was there, I never heard word one about the Scablands or Missoula flood or anything. And it's interesting because I, like some of you two, we lived right in the middle of it. So it's been really quite fun to, and quite an exciting thing in building my faith, to see that there's more to this state than just Mount St. Helens, even though that is a message itself, isn't it? Okay, are we up yet? Or trying to? So I have done a number of tours over there, and first of all I want to thank Michael Ord. He's a geologist that is from Montana, and he's the author of a couple books that we provide, and I'll share them with you at the end. I enjoy to read from him because he's studied it quite a lot since he lives in the source of it. So how many have gone on the tours with me? A few of you? Excellent, excellent. Well, I went about 4 times this year. So how many have been to Mount St. Helens? A lot of people have been to Mount St. Helens. So everybody knows about Mount St. Helens. So why does everybody know about Mount St. Helens and not the Scablands? We were there, weren't we? We watched it happen. I mean, it's really a unique experience, isn't it? When you go over to eastern Washington and view the effects of the Missoula flood, you know, it's impressive, but the thing is we weren't there. So we have to look backwards, don't we, into time, and look at what the evidence is and see it. With Mount St. Helens, it was different because we watched it before it erupted, during the eruption, and after the eruption. And when I worked with Paul Taylor and Lloyd Anderson in the Mount St. Helens ministry down there, we titled our talks, "The Message of the Mountain." It has a message, and it's interesting because the Missoula flood effects actually present the same message, only it's a long time ago, and we have to look backwards, and we have to look at the evidence, whereas Mount St. Helens we didn't. Does that make sense? Are we having, it's up now, okay. So the topic is the Missoula flood, a message of catastrophe, and that's exactly what it is. One of the verses that means a lot to me is the verse in Psalm there, "Come behold the works of the Lord, who has made desolations in the earth." And that's what we believe that God has done, to leave a message for us in the rocks that we have actually in our own state. It's quite impressive. And of course, everybody remembers Mount St. Helens, right? Back in May of 1980. It affected approximately 275 square miles of the geology and also the biology in that area. Very devastating, wasn't it? Well, what's pretty interesting is the Missoula flood overwhelms what happened at Mount St. Helens. There is a representation of approximately where Mount St. Helens is, and maybe a visual of what the area is. The Missoula flood affected Montana, northern Idaho, the Columbia Basin, the Columbia River Gorge, the Willamette Valley, out into the Pacific, and there's actually a channel cut out into the Pacific. Maybe, and I just roughly guesstimated this area right here, which is called the Columbia Basin, maybe 60,000 square miles compared to 275 square miles. A little bit larger, would you say? Yeah. It's quite an interesting thing, but we don't hear a lot about it, do we? Okay. See if I can get this to work. Well, why do we want to talk about an ancient flood anyway? And what does it have to do with biblical authority? It's just geology, right? And canyons and topsoil and rocks and boulders. What does it have to do with the Bible? Well, it has a lot to do with it. Anybody been to this area before, the Grand Canyon? Yeah? What's the message there, how it formed? Millions of years, right? Really? Were you there? Yeah? No? Well, that's basically what we're talking about. What the key issue is that we want to talk about tonight is the assumption for geological processes is a uniformitarianism activity. Long ages, short, small amounts of water over a long period of time. And of course, that is the foundation for the evolutionary process. Even though it's not much of a foundation, at least you have to have a long time period. Well, with a biblical assumption, we're talking about a recent creation and a flood event, catastrophe that caused what we see geologically. So there's a big difference, isn't it? It's like way far apart. It's two different sides of the coin in terms of what the question is. So which one is accurate? Which one is the truth? And so as an engineer, when we have a problem, we've never been there before, we look at the evidence and see what the best fit is in terms of what the evidence shows and the conclusion we come to. So we need to think about, and that's the whole idea about it, is look at the evidence we see even in our own state and ask the question, is there another alternative to this long time period that we hear in the story of the Grand Canyon and other geological places in our country? Does that make sense? So that's really the crux. Because if the long ages are really true, then recent creation and the flood have some problems. But the opposite is true too, isn't it? Okay. Uniformitarianism has been around for a long time. There was a gentleman named James Hutton back in the late 1700s that basically started the process of thinking about getting away from a biblical view of how the world came about and introduced, way before Darwin, an idea of naturalism. Things happened without the hand of God, different from what the Bible says. And you guys have heard this before, and we're just kind of reviewing that. The present is the key to the past. That's the basic fundamental look at what uniformitarianism is based on. What we see happening, for example, in the Grand Canyon where the Colorado River is taking out small amounts of material, if you translate that back, that's the present. If you translate it back, it has to be a long time period. Does that make sense? Okay. Geological processes take vast amounts of time. There's no biblical flood. There was another gentleman later named Charles Lyell, and he kind of codified the concept of uniformitarianism in one of the first basic books on geology, Principles of Geology. And he is considered the father of uniformitarianism, that viewpoint. He hated the Bible. And I thought this was interesting. This was his prime goal, to rid science from Moses, which I thought was a very interesting way to say it. At least, he was up front with what his objective is. There's a verse in Peter that talks about uniformitarianism, maybe. Let's read that. That in the last days mockers shall come with mockery, walking after their own lusts, and saying, where is the promise of his coming? For since the fathers fell asleep, all things continue as they were from the beginning of creation. He's looking at it in terms of creation, but it really is similar in that sense of seeing what we see now and translating it into what perhaps happened in the past. So we have a choice. Everybody has the same facts, right? We have the Grand Canyon sitting there. The question is, how did it form? When did it form? How does that relate to what the Bible has to say? Catastrophism. Most geological features were formed by, and this is what the Bible talks about, the Genesis flood and its after effects. We had how God made the world as a base, and then the Genesis flood came along, and from the descriptions in the scripture, it's pretty obvious that it was pretty aggressive in terms of changing the geology. And then, of course, some of the post-flooding events, the Ice Age and subsequent flooding. So, what about our Pacific Northwest? What's special about it? We know about Mount St. Helens, the volcanism that happened there, and we know about the Cascade Range. But it's interesting that the Northwest was shaped by three specific things. One, fire. After effects of the Genesis flood included volcanoes and volcanic vents, and we're going to talk about that in just a second. The second thing is ice. The Ice Age was produced a sheet of ice extending into Washington, Idaho, and Montana, as well as other places in the world, but we're talking about our area here. And water. A huge flood carved out the channeled Scablands in eastern Washington. So that's, when you think about the events that shaped eastern Washington, you want to keep these three things in mind: the fire, water, or ice and water. This is not a picture from eastern Washington. Okay? There's not a whole lot of this going on right now. But this is actually from Hawaii. Has anybody seen the volcanic flows from Hawaii? A couple of you have. They're quite impressive, aren't they? Well, you haven't seen anything yet. This is a kind of a map in the green showing the volcanic lava layers, the extent of the coverage in eastern Washington and down the Columbia River Gorge. Whoops, wrong button, sorry. If I can go back. Right in this area right here, geologists think were located many, many hundreds of fissures and vents for lava. Not like Mount St. Helens or the other Cascade volcanoes where they're kind of mountainous type volcanoes. These were fissures in the ground where lava oozed out and flowed in different directions. So what's impressive to me is the scale of this. up to 2,000 fissures, approximately 300 layers. And again, these are rough estimates. Some of them 100 feet thick. This is really what blows my mind. In this area in here, we're talking about lava that's 1 to 3 miles deep. Can you imagine that? I can't imagine that. Talk about scale up from what happens in Hawaii. Hawaii is nothing. And these are just rough numbers, of course. 50,000 plus cubic miles of lava. Can you imagine? I can't even imagine that amount. Covering 60 to 90,000 square miles of land. Mount St. Helens affected only 275 square miles. The latest lava flow in Hawaii was only 25 square miles. And it was pretty devastating, wasn't it? I'm really glad I wasn't living at this time. It might be a little bit of a problem, especially since I grew up right there. And you grew up right about here, right? Soap Lake. We would have been toast. Well, wait a second. That's not a good... okay. This is one of the canyons in eastern Washington, and I showed this just to show you what the lava layers look like if you haven't been there before. There's a different types of lava depending on its consistency, its composition, how fast it cooled, how fast it was flowing, etc. And it forms, it's interesting, all over eastern Washington in these various layers, there's what are called columns. Columns that are sometimes, 20, 30, 40, 50 feet high. And they're usually in kind of a hexagonal or pentagon shape. They're full of cracks because as they flowed and solidified, they shrank. And they formed all these cracks in between them. They kind of little standalone guys. And there's a lot of areas that are not columnar, but are kind of just like a conglomerate or clusters of small blocks of lava. And you might have the columns, and then the granular type, and then another column, and you'll have roughly 300 layers of these guys. And one of the interesting things is that over time, during weathering, during the hot and cold cycles, you'll have a lot of this crumbling off and forming what are called talus, which is a kind of a sloped area where all this, the crumbly materials will gather. If you want some large gravel, there's lots of it over there. It's not really gravel, it's more boulders. It's really impressive when you get up close to these guys, though. Here's a picture in Frenchman Coulee, which is near the Columbia River, where it shows the columns standing next to each other. Some of them are, like about this big around, but these guys are really big. They're really fat. They're like, I've seen them like 8 feet. What do you think? You've seen them that big, haven't you? They're huge. And they're about 40 feet high. After the Columbia Basin was covered with the lava, at the end of the flood, creation scientists believe, the Ice Age formed. And in our area, we had the Puget Sound lobe of this Cordilleran ice sheet that came down from Canada. That really didn't have any part of the Missoula flood or the Scabland formation. The Okanagan lobe came down near the Okanagan area, of course, and this had some effect on it, but the main one was what's called the Purcell lobe of this ice sheet, and I'll show you later where it actually formed, but this area right in here is where the ice dam formed that created Missoula Lake Missoula, and we'll look at that a little bit later. I just wanted to give you a picture of this, looking at the ice that formed. What caused the ice age? Well, it's complicated, very complicated. One of the main theories is basically a change in the tilt of the Earth in the past, which created a differential in the type of cooling depending on where you are, and in this particular case, affected the North American continent. We're not going to get into details on it because it is very complicated and it is a huge message by itself. Okay, theory based on the Genesis flood. Creation geologists feel that the ice that formed across the world was a result of Noah's flood. There's a couple verses that I thought were interesting. From whose womb comes the ice? Who gives birth to the frost from the heavens when the waters became hard as stone, when the surface of the deep is frozen? In Genesis, this is kind of a key verse. In the 600th year of Noah's life, on the 17th day of the second month, on that day, the springs of the great deep burst forth, and the floodgates of the heaven were opened. Keep this in mind, this verse, when we go to the next couple slides. Especially that phrase, the springs of the deep, great deep broke open. Another interesting little verse, thou dost break open springs and torrents. Cold winds. And we're going to talk about these in a second. The tempest comes out from this chamber, the cold from the driving winds, the breath of God produces ice, and the broad waters become frozen. He spreads snow like wool and scatters the frost like ashes. He hurls down his hail like pebbles. Who can withstand his icy blast? He sends his word and melts them. He stirs up his breezes and the waters flow. What does it take to cause an ice age? And again, we're talking at very top level, just kind of general ideas, because that's not the real subject of tonight. An abundant amount of moisture. Well, you had the rains. You had the oceans. Remember when it said the great deeps broke, the fountains of the great deep broke open? In that first verse of Genesis? You know, that's one of the things that creation scientists think is that there's an abundant amount of water supply in the mantle, and you had not only the water coming up during Noah's flood, as the mantle began to fracture and break and spread, the water was released, but also it was very hot water, causing the oceans to warm and sending hot spray into the air. And that's just a real simple view of it. Cold land areas. And what causes cold land areas? Well, you got to protect it from the sun. One of them is maybe the angle of the earth, but also the northern part of the world during the winter time is obviously the coldest part, just normally. But you have this abundant supply of moisture in the air that's warm, and it comes across the land, and if you have a lot of it, you're going to have a lot of snow accumulating, more than normal, way more than normal. And I can't even imagine what it was like during Noah's time. I mean, here's a little schematic. Whoops. Have to go back if I can get it. Warm oceans, cloud formations over the cold land mass. That's what causes snow today, right? It just depends on the amount of moisture. The other thing that we think might have happened during that time, during Noah's flood, is massive volcanism across the world. Even small volcanoes will change the temperature of the Earth's atmosphere. We've been able to record that. And the idea behind it is when the ash clouds go into the air, they form a cloud of ash which blocks the sunlight and obviously would cool down the land even more. We're not going to spend any time on this because, again, the idea is we know that the Ice Age happened because that's what it looked like. And our area is right in here. And we have evidence of the Ice Age even in eastern Washington. Who was from Waterville? Somebody, okay. You have north of the Waterville area, you have what are called recessional or terminal moraines, which as the glaciers push down, they push along kind of like a little bulldozer, pushing dirt and boulders and rock and such like that. And then when it stops and then recedes, it leaves a mound. And if you go north of, if you've ever been on Highway 2, it's pretty flat there. But if you go north of it about 5 or 10 miles, would you say? It becomes very rough and you kind of go up on a big slope like that. And that's the leading edge of the, I guess it would be the Okanagan lobe that came down. And not only that, it tends to deposit boulders that it carries along with it or pushes along with it. And I thought this was a very interesting, they're called erratics, by the way. They can be moved there by ice, or as we'll see later, they can also be a result of floodwater. Here's a small boulder north of Highway 2 that is a result of being pushed there by the ice. If you know, whoops, pushed the wrong button again. If you notice this pile of dirt right here, this is the road. You have a kind of bulldozed bunch of dirt right in front of this, kind of to the, what is that, the southeast a little bit. That is a huge boulder, I'll guarantee you. So how did that get there? It didn't grow there, did it? Well, that's a result of being pushed there by the ice. Okay, so we have fire with all the basalt, and that's very important to remember because that is a key factor in the geology that we see in eastern Washington right now. And then we have the ice, and the kind of the key of the ice is it formed the blockages, and we'll see that in a minute, that caused Lake Missoula to form in the first place. And of course, now we have the water. That's what we're going to get into. Come, behold the works of the Lord, who has made desolations in the earth. There's a message. Remember, we talked about that. What caused the channeled Scablands and carved the coulees? Coulees are the canyons, and we'll look at them and describe them in a minute, that are formed in eastern Washington that are fairly significant. Like, anybody been to the Grand Coulee? Banks Lake? Yeah? Did you know you were in a Missoula flood remnant? Yeah? It's pretty impressive, isn't it? Solid basalt rock on both sides and on the bottom. Remember that uniformitarian geologists all assumed they were formed over hundreds of thousands of years by gradual erosion, right? That's the basic concept. But is there a different alternative? This gentleman's name is Harlan Bretz, and he was a geologist. Actually, he was a homegrown guy. I think he went to the University of Washington for his degree. And he was a geologist, and he studied eastern Washington. He was very interested and intrigued by what he saw over there. What caused all this massive canyon lands and what are called scablands, where the soil is all stripped off, down to the bare basalt layers? What caused all that? So he spent many, many years traveling around by foot. You imagine in the 30s going over to eastern Washington? That really probably wasn't a lot of fun. But he was so interested in that because he wanted to know what was going on, because one of the problems he saw was there's no water over there. You got to remember, this is before Grand Coulee Dam, and you know there was a little bit of water, but there's not much over there, as you well know. The problem is, what he did is he came up with a concept that all of these canyons and the Scablands must have been formed by massive movements of water. And yet the problem is where is the water? That was the problem. And so as a result, his peers thought he was nuts, to be honest. They thought his theory about that was just an outrageous concept to even think about. And so what was interesting is that this man was ostracized by his fellows for years and years and years. But he kept at it because he knew that there was something special about what he saw in eastern Washington. So let's look. He was convinced that the Scablands and the coulees and the canyons were all formed by a catastrophic process, not the normal slow process. So what did he see? Now, some of these pictures are modern pictures, and they are not exactly what he saw, but he basically saw the same concept, but they were good pictures to show. Eastern Washington, the Columbia Basin, you've heard of the Palouse? Very nice farmland there. That's where I grew up. I ran combines and wheat harvest over there, so I know. There's very, very good soil over there. There's places where there's topsoil of, you know, I don't know, up to 100 feet perhaps. I mean, it is an amazing place over there. So he saw that in many places over there. But he also saw this, where all the topsoil was stripped off down to the bare basalt. Remember the basalt layers that we talked about? 1 to 3 miles, covering the entire Columbia Basin project or area. So he saw this and said, there's a problem here. He saw things like this, where we have topsoil remnants out in the middle of these Scablands, where there are just areas of topsoil that are remaining, but things are stripped off around it. How did that happen? This is an aerial view now. You got to remember, he didn't see this, but I wanted to show you this. This is south of Moses Lake. This lake was not there. That's a man-made reservoir. But all these coulees and potholes in solid basalt rock were visible to him as he walked through this area. This area over here has nice topsoil on it. This area is completely stripped. Great fishing right in this area, by the way. That's how I first discovered this area, was to fish in that lake right there. This is pretty impressive from the air. This, everybody know where Quincy is? It's a little bit east of Moses Lake. Quincy is right about up in here somewhere. These are called the Quincy Lakes right here. This area is called the Ancient Lakes area. And this is the Columbia River down here flowing this way. And you have these 4 lakes here that were actually carved into solid basalt. And then it flowed over, actually it started right here. I'll tell you about how that happened. But this is all a deep canyon right here, a fairly deep canyon, carved in solid basalt rock. And this is what? I don't know what we say, maybe those of you guys, maybe a couple miles wide, something like that, or a mile and a half, something like that. On our tours, we stand right on that tip right there and look at that. So he saw that from the ground. This is Frenchman Coulee, which is a little bit between Quincy and Interstate 90. This is the Columbia River. This is Vantage, just a few miles down the river from here. Those columns that I showed you before are actually right here. And you can see how deep that canyon was carved in solid basalt rock. There's a road that goes down there. You'd be pretty impressed, wouldn't you? How did that happen? Is there any water flowing here? Not a drop. That's what the problem was. But it certainly looked like it was what? Formed by what? Water. Dry falls. A lot of you have been to dry falls, right? Okay, so he came across this, roughly 400 feet deep here. This is an aerial view looking south. And this is dry falls, let's see, right? This area, well, right about like this. This is kind of the edge of it like this. It's roughly about 3.5 times bigger than Niagara Falls. Anybody been to Niagara Falls? That's pretty impressive, isn't it? Would this be impressive? Huh? That is huge. And I think Niagara Falls is something like 120 feet deep or something like that. That's about 400 feet. And of course, this is the canyon. Soap Lake is down this way. And this is the canyon carved in solid basalt down here. There's more coming up this way. But it kind of looks like there's a pattern of water flow, doesn't it? Now, he saw this from the ground, so a little bit different. This is Banks Lake, north of there. This is looking, I think, south. The largest area, I think, is roughly about 6 miles, and there's some areas where it's about 1,000 feet deep. It's pretty big, isn't it? A lot of us been there. It's a really nice recreational area there. There's a lot of water here, isn't it? Was there water there when Brett's was there? Well, there might have been a little bit, maybe. But not 30 miles. Do you know what that's Steamboat Rock right there? Anybody camp there? It's a national or a state park there. And that's solid basalt. So Brett saw this and said, whoa, I wonder what happened. Here's a little bit south, just a little bit south of Dry Falls in the lower Grand Coulee. There's a road there, and I think there's a truck there or a camper or RV or something. And you can see how massive that canyon is. There's a lake there. We'll talk about that lake in a minute. Like, where'd the water come from? This is Moses Coulee, which I think is one of the coolest places to be. Highway 2 goes right across it and back out. You go down in it and then go up again. It's really pretty impressive. But this runs from the north up by Jameson Lake and empties into the Columbia River. And I'll show you a picture of that in a minute. But you can see how deep that is. There's the road. There's fertile soil in the bottom. See these scarped areas there? Those are called hanging canyons. Imagine before the flood, there was a little bit of a valley there, and we had runoff, perhaps from Noah's flood, that drained into that and carved these little gentle draws or side canyons. And then the flood came, Missoula flood came and shaved those off and cut off where it hit the bottom of the main canyon. Does that make sense? And so you got what are called hanging canyons, and we'll talk about that later when it comes to the Columbia River Gorge. So he saw that and said, how did that happen? This is an aerial view of Moses Coulee. We were looking up in this area as it comes down and breaks out into the Columbia River Gorge area just south of Wenatchee. And you can see the pattern of water coming down through here and carving out these cliffs right here are monstrous. If you drive along this road, which is from Quincy to Wenatchee, it's an amazing geological feature. Just so impressive, you feel like a little ant compared to these rock walls there. This is a different area. Anybody been to Palouse Falls before? It's pretty, isn't it? It's really cool. Well, it's a remnant of the Missoula flood also. So Brett saw this, and in this particular case, there was water running in it, which is very unique in eastern Washington. So this is kind of going north here. So he saw this canyon and said, you know, that's a lot of water, but I'm not sure that that's enough to carve solid basalt rock, especially in this form where it's straight sidewalls and flat bottom. This is kind of a high-level aerial view of it. And here's the Snake River right here. Here's Palouse Falls right here. The Palouse River comes over here, down this way, makes a 90-degree turn, a sharp 90-degree turn, and heads south and dumps into the Snake River right here. Nice catfishing right in here, by the way. But, when Harlan saw this, now again, he was on the ground, he didn't see this. I think he would have been much impressed by this. He came here and noticed the Scabland area here, no topsoil, and then the river taking a 90-degree turn and cutting a narrow slotted, straight-walled canyon in solid basalt rock. And there was this river flowing in it. Just as a side comment, we now know that the Palouse River used to flow this way, the old Palouse Valley. And what happened is when the water from the Missoula flood came this direction and down this way, it kind of scoured along here and it found a little small low spot in this ridge right here of basalt and channeled itself this way and changed the course of the Palouse River. So this is what we see today. It used to go this way. Isn't that amazing? And dump into the Columbia River, of all things. Now, Harlan didn't know that, but I thought it was pretty interesting. This is another thing that Harlan saw. You've seen this before, a little bit south of, you've been there before? Yeah? It's a little bit south of, a few miles south of Soap Lake. It's a huge boulder. This is one of the places we go on our tour. This is not my tour group. For kids, it's permission by parents only, not me. But these are big erratic, a big basalt erratic that's out in the middle of this flat field. North of here is the end of the lower Grand Coulee, south of Dry Falls. And the idea is that when the floodwaters came and it got to Soap Lake, the side areas began to shallow out. There wasn't as much of a profile on each side to channel the water, and it spread out and dumped its load. As water spreads out, it's what? Slows down, doesn't it? So the rock and materials that were carried with it began to settle down. It was still going pretty fast, but it settled down in this area and dumped a lot of its load. Around this, there's these boulder fields, and there's not only chunks of basalt, but a lot of it is granite. It's interesting. This is just a little ways east of Dry Falls. This is called Deep Lake. This is a really neat area if you ever want to go in there too. There's a nice little park there. Beautiful area in there. This thing is monstrously deep and long and narrow. A lot of good fishing in there too, by the way. And there's a lot of these little potholes or holes drilled in the solid basalt rock. Somebody took like a rock drill and went like that, only on a large scale. So Harlan saw those and said, that looks like water, but where's the water? This is in, one of the, I think this was Moses Coulee, covered with sagebrush in the bottom, shows the straight walls on the side. This is the talus. The main question that plagued Brett's was, where did the water come from? One of the problems with eastern Washington, even though it's got a lot of fertile ground, it's very dry over there. 12, 14 inches of rain a year, is that about right? Something like that? That's not a whole lot to carve out canyons that are 1,000 feet deep in solid basalt, is it? Where did the water come from? That was his problem. Well, we now know where, you remember the water in Banks Lake and the water in Coulee in Dry Falls and then the lake south of it? There's a small little project on the Columbia River called the Grand Coulee Dam. And from behind this lake, they pump, I don't know if you can see them over there. No, well here, these pipes are actually large pipes that pump water over this ridge down into Banks Lake. That's where the water comes from today when we go there, because there's no rain over there. And here's a picture that shows the pumping pipes here and then a canal that goes along here and then dumps into the Banks Lake. The purpose of this is to create what they call the Columbia Basin Irrigation Project. The reason why Columbia Basin is such a great, marvelous place for agriculture is because of those pipes and this dam and that water. It's fed through a series of canals all over eastern Washington, through Quincy and Moses Lake area, down even in Pasco where I grew up. We used irrigation water pumped from this dam down in the Tri-Cities. So that's where the water comes from today. But this wasn't here when Brett's was there, was it? Well, that was a little bit of a problem, but then the light began to shine on what was going on. Over by Missoula, Interstate 90 goes through Missoula. If you look on the side of the mountain behind the town of Missoula, you'll see this cliff that has all these horizontal lines. They're about 35 feet in height. Those are now what they know are called, they're ancient shorelines from a lake. I wonder if it's called Missoula Lake. This is near the University of Montana. This is an interesting thing that was discovered over there. In a valley just north of Missoula, in the Camas Prairie, or Valley, there are these ripple marks, these mounds of horizontally laid, actually it's gravel, made of gravel. They're about 50 feet high and about 6 miles long this wide, 250 feet peak to peak. Here's an interesting picture. That's a road driving away. Wouldn't that be fun? Make a lot of time there, wouldn't it? So, very interesting. Okay. This is an interesting feature. This is south of, on the Columbia River, just south of where Moses Coulee dumps in. This is called West Bar. Actually, if you come from Quincy, that's one of our stops as we look at an overlook on this side of the river and see these. Look at the giant ripple marks there. It's about 12 miles in length from here to here and a few miles wide, made of gravel. That's interesting. Here's a picture from high up. Moses Coulee empties in up in here somewhere. And this is downstream. And this is what happens when a river or a large body of water carrying a lot of material, it goes around a corner like this. It's very high speed over here, and the water slows down here and it dumps its load. And that's what that gravel bar is. But it's not a small gravel bar, like the Snohomish River. You've seen gravel bars on there. This is like big. This is one that I didn't know about until I did this study. This is over on the Snake River by Lower Monumental Dam. And I thought this was pretty impressive. All these ripple marks on the inside bend of the Snake River, showing these ripple marks. Anybody ever seen ripple marks anywhere else? Does that look familiar? Where is that? On a beach, right? Very common, where you get water coming in and coming back out again. And it forms the sand in this ripplish pattern, doesn't it? Although these are like little tiny ones, aren't they? Imagine ripple marks that are 250 feet across and 50 feet high. What does that tell you? Must have been a lot of water, right? Okay, well, some of these evidences convinced geologists, especially as they got to the point where they could do aerial photography, that the Scablands were not formed over hundreds of thousands of years. They were formed suddenly by large volumes of water moving rapidly. Does that make sense? I mean, the evidence is outstanding. The lake was held in place by an ice dam blocking the Clark Fork River in Montana. And it held about, they estimate, right at over 500 cubic miles of water. Can you imagine that? That's a lot of water in a lake, isn't it? When the dam failed, all the water was released and flowed to the ocean in roughly about 48 hours. Here's a cool picture. I like this picture. It's kind of complicated, but we'll work through it. The ice dam was right here. Clark Fork is right here. I think it's Highway 200 or something like that goes up this canyon. Lake Pend Oreille is right around here. Lake Pend Oreille is, Lake Pend Oreille is right around in this area here somewhere. Anybody been to Lake Pend Oreille? Beautiful area, isn't it? You know how deep it is? Oh, it's deep. Has a lot to do with the glaciers and the Missoula flood. So anyway, the ice dam formed here, and over, they estimate, roughly 40 years, this lake filled, and in some areas 2,000 feet deep. Like I said, 500 plus cubic miles of water behind this little ice dam right here in this canyon where the Clark Fork River ran. Flathead Lake is, I think, under this lobe right here. Then, at a certain point, the ice dam failed, and the water broke loose, draining this lake in about 2 days. And it ran through near where Spokane is, right around in here. And it happened to run into what we think is maybe another lake that was formed by this lobe in the Columbia River Gorge, I'll call it, at that time. Lake Columbia. So this lake collided with that lake, and this is the Columbia River runs like this. And there's on this side are the foothills of the Cascades, so it provided a natural dam, plus, there's a number of ridges that run this way. And so the water then funneled its way across the Columbia Basin area from kind of this area that way, along here like this, in a very complicated pattern, stripping off all those topsoil areas that we talked about and carving the coulees that we see. Down here is Wallula Gap. It's a very narrow gap where the Columbia River goes through near Pasco. I used to swim right there. And all the water pooled behind there and created what's called Lake Lewis, backing up into the Yakima Valley and in the Walla Walla Valley right here. And as it rushed through here, it went down the gorge, the existing Columbia River Gorge, although it was smaller at that time, and came to another block here and formed this little lake. These are kind of like retention ponds, only they were not ponds. They were big lakes. And the water rushed down the gorge into the Portland area, went down into the Willamette Valley, and there was another blockage here that kind of made this lake form, and then it rapidly went out here. And as it went, it did a lot of damage, especially in these areas right here. This is where how many have gone down the Columbia River Gorge? Beautiful, isn't it? All those hanging waterfalls, all because of the Missoula flood. This is kind of a satellite view of eastern Washington. And this is kind of like these blue arrows are the kind of the general path down the Grand Coulee, down this, or this is Moses Coulee, I guess. This is more like the Grand Coulee area here. Here's where's the arrow there? The Palouse Falls area here. Here's Pasco, Wallula Gap. This is out here is the Columbia River. And then down the Columbia River Gorge and out. Isn't that impressive? That's a lot of area, isn't it? This is kind of a picture of what the ice dam might have looked like in northern Montana. This being south, Missoula way down here somewhere. And that dam formed, it's the leading edge of the Purcell lobe. This is kind of a picture of what Missoula probably looked like at the height of the flood, or height of the lake. Here's Interstate 90 coming right through here. I hope you have your yellow submarine with you, because this would not be a good trip at this time. And that's the mountainside right in here where we saw those lake shores. So when the dam broke, whoops, sorry, wrong button. We had a wall of water, a couple hundred to 300 or 400 feet, traveling at about 50, 60, 70 miles an hour across the Columbia Basin, down the Columbia River Gorge. When it came to the narrow areas, like at Wallula and down the Columbia River Gorge, maybe 60, 70, 80 miles an hour. It's hard to tell. These are kind of calculation guesstimates based on volume and time and the size of the area. How many would want to be in Pasco at this time, or Soap Lake? Not a good plan. It's kind of like when Mount St. Helens blew up. You probably didn't want to be very close because you could not outrun it. But you got to remember the scale of this, the entire Columbia Basin. This is really amazing to me. This is probably what Dry Falls might have looked like. This is an artist's rendition right here. There's the ridge and the water kind of flowing over it. There's perhaps a little dip at that point. That's why it caused that. You remember those pothole areas that we saw, those little pits in the solid basalt? How do they form? Well, as water goes over it, it forms little vortices that kind of drill its way down into this loosely, well, it's packed basalt, but remember it's got these cracked columns and a lot of cracks in it from when it formed and cooled, and it kind of just drills down into it or lifts it out and carries it away. The canyons are interesting. You remember the mouth of the Moses Coulee down by the Columbia River, that one picture? It's pretty wide there. We think that's where the canyon started. As the water came over the plateau and the flat part, it came to the edge of the Columbia River and spilled over the top. like it is in that waterfall area there, and it started to create vortices underneath these columns of cracked basalt, and these, as it worked its way underneath, it would collapse. And then it would move upstream. And it would move upstream as it continued to work, and it was very rapid. Does that make sense? So how far is it from Soap Lake to Dry Falls? How many miles? 20 miles? In 2 days? Moving all that rock? That's pretty fast. Okay, and then of course, it stopped at Dry Falls, I think, basically because it ran out of water. It's pretty simple. So this is kind of the theory about how the canyons may have formed very rapidly. So here's a kind of a pictorial of Portland area. It was devastating on the Portland area. This is what it kind of Portland was look like. There's a building right here. They figured it was about 400 feet deep in Portland at the height of the flood. That's a lot of water, all moving downstream. This is the Willamette Valley right here. You've been in the Willamette Valley? Pretty cool farmland, isn't it? Guess where the dirt came from? Anybody ever think about that? It didn't grow there. It came from eastern Washington, I think, or a good portion of it. And here's the reason why. Brett saw this rock right here in the southern part of Willamette near McMinnville, up on a ridge. This is granite with the same composition as granite from northern Montana. And this is a huge rock. I mean, this is like 6 feet high and maybe 12 feet wide. I mean, it's big. How did that get there? It was probably carried on a chunk of ice that was floating in the water. And then when water receded in the Willamette Valley, it kind of hit the ground and just melted, and there it is. And they're all over the place in the Willamette Valley. This is not just one. This is the Columbia River Gorge. The gorge we see today is not the gorge that was there when the Missoula flood came through, because it is bigger and wider and deeper. Remember those hanging valleys in Moses Coulee? Now we have the same thing, especially on the south side of the Columbia River. The only difference is there's a lot of water down there. And that's why you get the falls that are kind of dotted along the south side of the Columbia River as you drive along Interstate, 82 or 84? Something like, whatever it is, yeah. So, see, how are we doing for time? 5 minutes, okay. I think I'll skip over this. One of the controversies is how many floods there have been. Some people think there may have been up to 40 because of layering, mainly in the Walla Walla area. This is called Burlingame Canyon. As the water backed up in there, it deposited layers. And there's a lot of them there. So they think there might be a lot of different floods. There's arguments about that. Michael Ord thinks not. This is in the Yakima Valley. This is an interesting plaque. After the creation, or the secular geologists figured out what was going on with the Missoula area and the Camas Valley and all that, they said, Harlan, I think you might have an idea. And they wrote a plaque to him in 1950 that said, who patiently taught us that catastrophic floods may sometimes play a role in nature's unfolding drama. Ideas without precedent are generally looked upon with disfavor, and men are shocked if their conceptions, what does that say, of orderly world are challenged. Does that sound about right? That's what we're facing. Harlan faced that, and he wasn't even a Christian in the sense of trying to promote a Christian viewpoint. He was just trying to figure out the geology. But it was really cool, at least the secular geologist accepted that. The conclusion of it, it doesn't take millions of years to drastically change the surface of the earth. What would you expect to see if the Missoula flood was scaled up to a catastrophic event, the scope of Noah's flood? What would you expect to see around the world? Well, anybody been to Willamette Valley? Yeah? Well, there's a lot of soil and material that's gone, isn't it? And there's remnants there, just like in the Scablands. Devil's Tower, same thing. Well, this is the headwaters of the upper Grand Canyon right here. That looks very familiar, doesn't it? And the Grand Canyon itself. Bryce Canyon, I love Bryce Canyon. It's cool. If you look across the valley 50 miles away, you see the same layers, only without the pinnacles. Where'd all the material go? The last thing I want to share with you, this is really cool. The flood took all the topsoil away, but that is growing in eastern Washington. This is in Dry Falls State Park. It's an area of recovery, just like Mount St. Helens is. Look at that. Isn't that cool? These are the hummocks just downstream from Mount St. Helens. I think this is one of the biggest messages for me. God is busy doing the same thing in our lives, taking spiritually dead people and making us alive. In 2 Corinthians it says, therefore, if anyone is in Christ, he is new creation. The old has passed away. Behold, the new has come. Doesn't he do that? That's the job he's doing, isn't it? Taking dead land and making new out of it. For Christ also died for sins once for all, the righteous for the unrighteous, that he might bring us to God. Being put to death in the flesh, but made alive in the spirit. Well, I think you got to see it for yourself to really believe it. It is amazing if you're there. You just got to get there to get the sense of it. So what we offer in our Apologetics group are tours to go there. And right now we're doing 7 stops. That's a full day, but we do it. And you can come, if you get a group together, bunch of grandkids, schools, neighbors, friends, church, give me a call or email me, and I'll go anytime. I'm retired. I'll drop. I won't go fishing. I'd rather go with you guys. Okay? We could work something out. Dry Falls has some big fish in Dry Falls Lake. That's it. I'll stand up there, I guess.
Thank you, Ron. That's a lot of information to cover there. And for those of you that have been to the Mount St. Helens tour, you'll recognize some similarities of land formations there. So we're going to take some time for Q&A. And if you have a question, raise your hand, and I'll bring the mic around. And while you're thinking of your question, I'll remind you that we support this ministry through free will offerings, and men will come by, and if you want to contribute to the ministry, feel free to do that. You can either do it in the plates, or there's donation boxes in the back too if you'd rather do that.
Can I say one more thing?
Yeah.
These are cool. These are the 2 books and DVD by Michael Ord that talk about the Missoula flood and a lot of things what we talked about. These are really great resources. And this is the kind of the quintessential book for Mount St. Helens, Footprints in the Ash, with the same story, like you said.
Yeah. Thanks, Ron. So raise your hand if you have a question.
Yeah, I was just wondering how this is apologetic, or how it's going to make us believe that this was something that they didn't already know about. I mean, in other words, the Bible, first part of Genesis, talks about the layer of water, and most scientists agree, for instance, whatever their other beliefs are, at least in this arena, that that the earth was hot at the beginning. It was molten. and there was a layer of water that rose, and then at some point when it cooled off, it created a flood. I mean, a worldwide flood.
I think I'm still on.
Yeah.
But go ahead if you want to.
No, you're right.
Well, I agree with you, because we have the creation, it's kind of like a phased thing. We have the creation events that had those type of things. You know, I can't imagine what it was like as God was forming the earth. I would assume it would be fairly, I guess, geologically chaotic, let's put it that way. But I think what we're trying to do here is look at evidence that helps us validate what Genesis says about the first the initial creation, but then the follow-up flood that that Noah went through, and the potential geology that was going on behind that. And to me, what it means is that if indeed what we see and believe today is long age, slow efforts in changing our geology, then what the picture that the Bible presents a few thousand years ago about catastrophic processes is invalid, or doesn't hold a lot of water, no pun intended. Okay? So the question I have in my mind, is there evidence that's scientifically solid that catastrophic processes are indeed real and really can affect the geology in a massive scale? Mount St. Helens was a good example, and the flood, I think, is even a better example in our local area. So that when I go to the Grand Canyon, I can say, they say it took millions of years, and my question is, really? Is there another potential way that it happened? Could this have been a artifact of Noah's flood time? Does that make sense? And what I'm saying is, to go over there and visualize what's happening either at Mount St. Helens or the Scablands, and we have solid evidence that it was catastrophic, it's not a question. That's the key thing. It's fact that even all the scientists think has happened. So then I can say, yes, catastrophic processes are real, and I'm standing in the middle of Moses Coulee looking at 1,000-foot walls in solid basalt. I'm saying, this is impressive. And I go to the Grand Canyon and said, this is impressive. Could it have been another catastrophic process on a larger scale? Does that make sense? And that's all I'm saying is, so that's the value and the reason why I think we need to consider the evidence of Mount St. Helens and the Scablands, is because it supports or validates what we know the Scripture says. It's not absolute proof, because none of us were there, right? But all we want to do is look, is there any evidence that validates that?
But what I'm saying is that normally one would have catastrophic processes. I mean, you know, if you had
To start.
an atmosphere like Venus.
But that was to start. And then but you got to understand, the message is out there is not catastrophic processes. It's uniformitarian, slow age, time, one grain at a sand thing, efforts or processes.
Ron,
Yes.
let's
Go
take another question back here,
Yes.
too, and we can come back to that.
Yes.
Yeah, two places I've been that you haven't touched on here, but maybe you can answer is in Vantage, the ginkgo petrified forest, trees, you know, various types, and then in Yakima, top of the hills,
Right.
there's a big petrified forest. The whole hillside east of Yakima has got petrified logs all over the place. Would they be Missoula or maybe the Great Flood? Or
I don't think they were Missoula, because they're too high up in both places. And they're on the east side of the Columbia River Gorge for the ginkgo. And of course, Yakima is on a high plateau above the Yakima Valley. The waters flooded that area in kind of in a recessionary type method, but it didn't go that high. So the answer is, I don't think it has anything to do with it. That's probably more in line with the Genesis flood now, because we know that the waters covered all that area.
Other questions? If you put up your hand, I'll bring the mic around. We'll take a few more questions, and afterwards Ron will be available at the back too.
What precipitated the Ice Age?
Oh, that would be a long process to talk about that, yes. Well, I think just in summary, the way the creation scientists look at it is that towards the end of Noah's flood, in the years afterwards, the flood lasted, about a year total? And you had a massive amount of water going into the atmosphere. You need a lot of water in the atmosphere so that when the winds blow it over the land, then you have a kind of like a never-ending cycle of water moisture, if you will, to create that much ice and snow. And if you then had a lot of volcanism covering the area or the Earth's atmosphere with dust and dirt, blocking the sunlight, you'd also cause the mountains to even get colder for a longer period of time than normal. And that's kind of like the short, really short, condensed version of what I think probably happened. And as a result then, you had a large amount of ice and snow forming over a relatively short period of time, a few hundred years maybe. I mean, and that's just because it's a very complex problem of the Ice Age.
Ron, you mentioned Michael Ord. He's also written, he's a geologist,
Yes.
and he's written a book on the Ice Age.
Right.
So given our assumption of approximately 6,000-year-old Earth, where does the Missoula flood fit in time-wise in that chronology?
Yes.
Do we have
Well, we had Noah's flood roughly, 2,000 years after creation? 4,000 years afterwards. And so the idea behind at least the creationist viewpoint is the Ice Age followed Noah's flood. And of course, that's what caused the Purcell lobe to come down there and block the Clark Fork roughly 400 or 500 years after Noah's flood. So that's kind of the time frame that we would look at.
Okay, one more question here.
Yes.
We'll take one more question.
You're talking about an Ice Age, but this Ice Age would have had to been subsequent to Noah's flood. And if it's subsequent to Noah's flood, it's affecting all the people that are alive, which is only 8 at that time. But that's the birthplace of humanity as we know it.
Well, not where the ice was, though. The ice didn't, where we think Noah landed is not in the northern hemisphere. I mean the north part, where we showed the ice coverage, where the actual ice glaciers formed. It was way south of that. So they wouldn't have been, quote, directly affected.
Okay, one more question. Yeah.
Yes, thank you very much. But my question is on if you believe the geological evidence supports a rapid shift with the 23.5-degree tilt in conjunction with the flood that may have precipitated some of this volcanic action.
It's possible. I don't know. That's a good question. I think it may have had something to do with aiding the formation of the ice shelves, but I'm not sure because I don't know of any correlation directly between them. All I was saying is that that's one of the proposed concepts that causes glaciation in Ice Age, not necessarily that it was directly related to the Missoula flood timing. Does that make sense? Although it could have been.
My question was just, did you see any
No.
geologic evidence to support
No.
Okay, well, we're going to bring this to a close. Again, thank you,
Sure.
Ron, for presenting that. And just to summarize, if we can bring up the last slide there, I just want to introduce again Mike Riddle as the speaker next month. He's been here at least once every year, so many of you have listened to him a number of times. He's going to speak this time on a topic called Establishing, Defending a Biblical Worldview. How do we compare the biblical worldview with the secular worldview, that of the materialist and the atheist? So he's going to talk about that, different aspects of that. And remember that also when he's here, he's going to do that basic creation training program. Yes, it is up in Ferndale, but it's not that far from here for those of you that have never been through that course and would like to take it. And then on the Saturday evening, on the 28th of September, he's going to do that youth night. And for that, all the youth in the area churches are invited to come that. And that is in Lake Stevens, Calvary Chapel, Lake Stevens. So that's what we have. There are flyers on all of these events on the back table there. And if you, at home, of course, you can just access the website, the apologeticsforum.org, and all of these events are described in great detail. And also, just to put in a plug, on the web page, the very front page, there's a menu item called